Come here, Baxter. Come here, bud.
Come here. Okay. Okay. No, that's too close. Alright. Conduction.
Hey guys, welcome back to our channel.
Today we'll be showing you different examples of
Physics
physics stuff. Hope you enjoy. Like, comment, subscribe down below.
Disclaimer, we shot this video over like a
The
week.
past week. And
Yeah.
we look like crap in half of it. So,
So yeah, so
Don't
some
mind
of it
us.
might be like in the morning and some of it might be like at 11 o'clock at night and some of it might be like a whole nother day.
so don't mind us. Evaporation is a type of vaporization that occurs on the surface of a liquid as it changes into the gaseous phase. When the molecules of the liquid collide, they transfer energy to each other based on how they collide.
When a molecule near the surface absorbs enough energy to overcome the vapor pressure, it will escape and enter the surrounding air as a gas. When evaporation occurs, the energy removed from the vaporized liquid will reduce the temperature of the liquid, resulting in evaporative cooling.
Our next phase change is freezing. Here you will see I have a
It's a cup of water.
cup of water.
Yeah. And when freezing occurs, that means that it's a substance going from a liquid to a solid.
Condensation is the change of physical state of matter from gas phase into liquid phase and is the reverse of vaporization.
As you can see in the video,
Condensation, my dudes. You see that? That's condensation.
oh yeah, it's right there.
Your head.
The steam from the boiling water in the pot turned into the liquid phase, as you can see on the stove.
When exposed to room temperature air at pressures of 1 atmosphere, the frozen carbon dioxide turns directly into gaseous carbon dioxide.
Gross. Scarlett, stop.
Shoot. First, we're gonna
Wait, do it again. Do it again.
First, we're gonna preheat our convectional oven to 350 and press start.
Where's the egg?
She right here.
Then we're
so you can hear it. With a heating element around that provides heat. A small fan like this one circulates the air in the cooking chamber. And the cooking chamber is in here. Come on over and see. Convection ovens may include a radiant heat source at the top and bottom of the oven. Here, it improves heat transfer and speeds cooking from the initial cold start. She's done. She is ready.
Wait, let's see.
You gotta test it first.
Yeah.
Perfect.
Next, we're grilling chicken wings to show conduction.
We're gonna let them cook in there for quite some time.
Nice.
Yep.
Conduction is the process of heat transfer by direct contact of the food to the heat source. This usually occurs at higher temperatures, thus creating a searing effect.
Infrared grilling is a good example of conduction. Conduction also occurs at the grilling surface, or also known as the grill grates. We can keep that in.
Good enough. Next up is radiation. So we're going to be making mac and cheese in the microwave for radiation. And basically what radiation is how heat moves through places where there are no molecules. Radiation is actually a form of electromagnetic energy. We learned that electromagnetic energy is moving in waves. Well, radiation is heat moving in waves.
Radiation does not need molecules to pass the energy along. So now we're gonna make some mac and cheese by Cracker Barrel, and it's not sponsored, and we have to put this in the microwave. And microwaves are a type of electromagnetic radiation. It is transmitted in waves or particles at different wavelengths and frequencies. This broad range of wavelengths is known as the electromagnetic spectrum. Now for entropy, we have balls.
But not just any balls.
Tennis balls.
Tennis balls.
And they're balls for the dogs. Here, we got one tennis ball. How many ways can you arrange it, you might ask? Just one.
Just one way.
Just this way.
But if we add another tennis ball,
You can arrange it more ways.
multiple ways
I
of arranging the
know.
tennis ball. If you add a third tennis ball, multiple ranges.
The higher the entropy, meaning the more ways that a system can be arranged,
The more the system can be disordered.
yay! For the first law of thermodynamics, rubbing your hands together generates heat on your palms. This is not actually creating energy. The work of your muscles takes the chemical energy out of your body, changes it to work energy in your muscles, and then into friction energy in your skin. You've actually moved energy from your body through your muscles and into your hands. The first law of thermodynamics requires that the total energy of your body, muscles, and palms is the same both before and after you rub them together. I'll demonstrate. It's really hot now.
Okay, so for the second law of thermodynamics, we know from everyday life that when left to itself, a system which is initially not in equilibrium always changes towards equilibrium. So while the opposite direction does not happen, there is nothing in the first law that prevents a system to move in the opposite direction since energy is equally conserved.
Consider a gas that fills a container. About half of the molecules are in one half of the container. The rest are in the second half. Each molecule can move freely, so in principle, nothing prevents all the molecules to occupy only one half of the container. But left alone, it never happens. But the opposite direction does happen. If we begin by filling only one half of the container with molecules, after some time, they fill the entire container.
Say that we filled this container up halfway, the molecules wouldn't just, fill up the container halfway because they're freely moving particles. They would fill up the entire container. Whereas if you filled up, like, say, a cup of water,
it's only going to fill the
like
half
a cup
that
of water,
you filled in.
Halfway, it would only fill up the cup halfway. Fill up this halfway with gas, it would fill it entirely.
Yep, you can see that the whole thing is kind of frosted,
Yeah.
That means all of it's in there.
Yeah. Thank you. This process is irreversible. We lost information during this process. Initially, we knew that all the molecules are in one half, but at the end, we cannot constrain the location of each molecule inside the container. The final state is thus less ordered or more random than the initial one. Okay.
Alright guys, that's it for our video today.
If you liked it, give it a thumbs up. If you didn't, still give it a thumbs up.
We'll be back next week with a new video.
Make sure to like, comment, and subscribe down below.
Bye!
Oh. You recording? Yeah.
Wait. Supposed to return when exposed to room temperature air.
Oh my.
Alright. Yeah. Are you in the fourth part?
Yes. The ice cream.
You hungry?
Is the process of heat transferred by direct contact of the food to the heat source. No. Messed that one up too.
Conduction. Conduction also occurs at the grilling surface.
Why can't you talk? You can never talk.
Because I forget to do that again.
Yes.
No.